Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're going to be jumping into a 9th grade topic, solving and graphing inequalities. Now, if you have any question about what you see here today, remember you can always put in the comment box below or visit me on Facebook at Tutor Me Senpai. You can always tell me about your homework that you like to see on this channel there as well. If you do find this video helpful, remember to leave that like. It really helps the channel. And while you're at it, hit the notification bell and the subscribe button so you know exactly when I drop my next videos. But without further ado, let's talk a little bit more about inequalities. So before we jump into our question for today, let's talk a little bit more about what you need in order to actually solve an inequality and therefore graph the inequality. So an inequality is very, very similar to just an equation. So if you had an equation like this, and they ask you to solve for x, you would simply subtract 5 from both sides, and you would get x is actually equal to 5, right? Well, for an equality, such as this, you're going to do the same thing. When solving for x, you're going to subtract from both sides, and you get x is less than 5. So the way you solve is going to be very similar. However, it's not always the case where you can change this equal for whatever sign, as you see in this example. Here's an example where you can't do that. So if you were to try to solve this the same way, you would then subtract 10 from both sides, and you'd be left with a negative x less than a negative 5. And then you would divide that negative 1 so you can have x by itself, right? However, this step here is wrong. The reason why is because whenever you're either multiplying or dividing by a negative number, you have to do something with the sign. You don't have to worry about this when it's an equal sign, but whenever you have these inequalities, whether it be greater than, whether it be less than, whether it be greater than or equal, or less than or equal, regardless of what sign it is, you have to switch it. If you're going to multiply or divide by a negative number, regardless of whatever number it is, as long as it's negative, you're going to have to go from one to the other. So if it's a greater than, it becomes a less than. If it's a less than or equal, it becomes a greater than or equal. And I'll show you how. So let's back up a few steps here. So you subtract 10 from both sides and you get negative x is less than negative 5. So now we need to get this x by itself, so let's make it positive. And you can either divide by negative 1 or multiply by negative 1. Well, whatever you do to one side, just like an equation, you have to do to both sides. So that becomes a positive x and a positive 5. But this is saying x is less than, right? But if you're going to divide or multiply by a negative number, this becomes greater than. And you can test it out. Pick any number greater than 5, plug it in here, and see if it makes sense. So let's say we pick 7, right? This says 10 minus 7 is less than 5. Well, what's 10 minus 7? 3. And is 3 less than 5? Yes. So you see, whenever we're going to be dividing or multiplying by a negative, we have to remember to switch the sign. Now that we've talked about how to solve inequalities, let's talk about how to graph these inequalities. If you're going to graph an inequality, you're going to have to start with a number line. And a number line is quite simply a line with numbers on it. So if I had a 0 here, we highlight the integers, but there really is all these numbers in between. And you don't always have to go negative. It really depends on your inequality that you're looking at. But here's just a basic number line where in the middle we have 0 and we go up to 3 and we go down to negative 3. But these arrows here mean that we're going to keep going to infinity. So you can think of that as a positive infinity, and this is a negative infinity as far as how far it's going. It doesn't stop. We just took a little snippet and we're focusing on this, but in actuality, this doesn't stop. If you want to graph an inequality, a simple inequality like this one, you just have to figure out which x's make this statement true. So we're going to be looking at all x's that make this statement true. So x less than 1. Can x be 2? No. Right? Can x be 5? No. Right? How about x is negative 30? Yes. Right? X negative 30 means it's less than 1. So how we graph this is we're trying to figure out all x's that make this true. So we're going to start with this number. We find this number on our number line, and we're going to put a circle. Now I'm going to put a circle on top, but sometimes you might see people put a circle on the actual line, but because I'm writing in red, it might get a little bit too crowded. So I'm just going to write on top for this example, but you can choose however you want, or at least whatever they're telling you to do, you do that. But I'm going to put it above so you can see what I'm trying to do here. So we start here at 1. Now you notice I haven't filled this in. That's because whenever you're dealing with inequalities, this is very different from this, and this is very different from this. This means strictly less than. This means less than or equal. So we can have an equal, right? Whatever you're less than here, you're not including, you are including here. Likewise, this means strictly greater, and this means you can actually equal it, greater than or equal. So whenever we're looking at these inequalities, we have to figure out, are we going to include whatever number is here? This tells me I'm not going to include it, so we don't have a filled in circle. If this was a less than or equal, then I would simply fill this in. So we can move on with the equals because after this part, it's exactly the same. All x's less than or equal to 1. We already talked about how 30 is an option, right? But there have to be more than 1, right? Because we're looking at all possible x's, and this goes to negative infinity, and this goes to positive infinity. Well, we already saw that it can't be bigger than 1. So this is an option, this is an option, this is an option, this is an option. All x's lower than 1 are options. Well, how about all these little x's in between? The halves and the negative halves and the negative 1/2. Well, all these points are also less than or equal to 1. So what we do is we put a line extending from our point all the way in a direction of whatever infinity that makes sense. In this case, we're not going positive, we're going more negative, so we're going to put a line in the direction of negative infinity. All x's less than or equal to 1, we start with 1, we fill in a circle because it's equal to, and then we draw a line all the way towards negative infinity. And don't forget your arrow. So now that we've talked about how to solve an inequality and how to graph an inequality, let's put both of those things together to solve our question for today. As you see, we have 5 minus 1/2 x is greater than 10. We want to find all x's where this is true. So we're going to attack this very similar to how we would attack a regular equation. So the first thing I would do here is try to isolate x. Well, let's move this 5 over to the other side. So let's subtract both sides by 5, and then we're left with negative 1/2 x greater than 5. And remember, we only flip the sign if we're multiplying or dividing by negative, not when we're subtracting numbers or adding numbers, only multiplying or dividing by a negative, okay? And as you see here, we have this negative 1/2 in front of x. Well, we have to get x by itself, so we can multiply by the reciprocal. Well, what's the reciprocal of negative 1/2? Well, the reciprocal is just going to be negative 2, right? So we multiply both sides by a negative 2, and these cancel out, right? So you have x Well, remember, it was a negative, so we're going to swap this, and then this becomes a negative 10. So now we've solved it, right? But now we want to graph it as well. So we start with our number line. And because we're already looking at negative 10, I don't recommend starting with 0 in the middle. Instead, start whatever number is here. Start with the negative 10. Just go straight for that. And if you want to put more numbers here, you can, but you don't necessarily have to, because what's important is the arrow and which direction is pointing. So we have this negative 10, right? We're going to start here. We're going to have a circle. Is it going to be an open or closed circle? Do I need to fill this in? Well, we look at this, and we see that there is no equal sign here. So if there's no equal sign, we don't fill it in. Okay? Now we look at which x's will make this statement true. X less than negative 10. So if I choose 1, right? 1, is that less than negative 10? No. All right? So 1 is not going to work. How about if I choose 10? Is 10 less than negative 10? No. It's not going to work. Well, what do these have in common? 1 and 10 are on this side of negative 10, right? They're higher. As you're adding numbers, you're going up, increasing towards infinity. You're getting bigger and bigger and bigger. Well, we already said that this is not going to be true. So if these two aren't true, you can kind of just make the next logical jump to say that none of these are going to be true. So we're only looking at stuff over here. Well, let's check it to make sure. Pick any number on this side and see if it's less than negative 10. How about negative 20? That's going to be on this side, right? Negative 20, is that less than negative 10? Yes. So if we have something that's successful, we know that all of them on this side are going to be successful. So we make our arrow pointing towards a negative infinity. So we don't fill in a bubble. We make our arrow pointing towards negative infinity, and now we've graphed it. So our answer for today is going to be x is less than negative 10, and our graph is going to point from negative 10 towards a negative infinity. A little extra information for you. If someone wanted you to write this in interval notation, instead of having it in this kind of notation here, you can easily translate this to interval notation by utilizing these negative infinities and positive infinities and your parentheses and square brackets. Well, in this case, we don't have any square brackets because we don't include this 10. Well, in negative 10, right? But we know that this is going to be our cutoff. We're not going to get any bigger, and we're not even going to touch this negative 10. So we're going to give it a parentheses. And we're going to get infinitely smaller. So we're going to have our negative infinity here, and then your comma. So you can translate this in interval notation by saying parentheses, negative infinity, comma, negative 10, close parentheses, because we don't fill this in. And you never can hold onto a negative infinity or a positive infinity. So this never gets a square bracket. But if this was filled in here, you would then make that a square bracket, but it's not. Well, I hope you're able to follow along with today's example. And I hope that if you had any questions, that you wrote them down, because I want you to put them in the comment box below. And I want to read those and see if I can help you if I can. If you have any question about your own homework you'd like to see on this channel, remember, you can always visit me on Facebook at Tutor Me Sempai, and you can tell me all about it there. If you found this video helpful, remember to leave that like. It really helps the channel. And while you're at it, hit the notification bell and smash the subscribe button so you know exactly when I drop my next videos. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.